Hi folks, Unreal Engine 5.2 is now available and further expands UE5's groundbreaking toolset as it continues to deliver on the promise of making Unreal Engine the most open and advanced real-time 3D creation tool in the world. Learn about the new functionality, feature refinements, and stability improvements at unrealengine.com/feed and download 5.2 from your launcher now. Unreal Fest returns to New Orleans from October 3rd through 5th, 2023. We're looking for speakers to showcase the inspirational work they are doing using Unreal Engine or other epic tools. If you've got something to share with the community, we want to hear from you. Journey to the feed for more. Are you ready to continue your path to real-time animation success with other like-minded, experienced professionals? Applications for Unreal Fellowship animation are now open. The Lord of the Rings Gollum returns to Tolkien's Middle-earth to expand upon the adventures of the Twisted Hobbit. Daedalic Entertainment explains how it turned to Unreal Engine and its functionality to craft a new vision of the beloved fantasy landscape while expressing the challenges of working on a gigantic IP. Warping over to this week's Community Spotlights, Gamble Entertainment Group is leveraging Unreal Engine 5 to bring about their first feature film, in which Quaid Branson is abducted by aliens and sent off to a mining colony on the outer rim of the galaxy. Once he makes a harrowing escape with an unlikely friend, they finally return to Earth with grave and dire consequences for the entire planet. Learn more about Mischief Upon Mischief on their website. Environment and lighting artist Diana Karakushian's latest team project sets the tone for a fantastic scene that shares knowledge internal to the team and externally with other industry professionals while working with Unreal Engine 5 to aid in the creation of this cinematic piece that takes us on a journey of a lone warrior with a cursed affliction venturing into a forgotten, isolated temple in search of a cure. Let them know what you think of Alder's Bane on their ArtStation. Discover a universe where time seems frozen, gravity is unstable, and dimensions constantly shift in this first-person puzzle game by SHK Interactive. Explore strange and enigmatic worlds, but beware, every action you take can have unforeseen consequences. Wishlist Disorder on Steam. Thanks for watching this week's news and Community Spotlight.
That's fine. So hopefully we're in today. Can y'all hear me now?
We can. Yep.
Oh, can?
Yep.
Can the community hear me? Maybe. Where am I still muted? This is fun. I don't know where I'm muted, kids.
I can hear you, so.
We can hear you.
Yeah,
All
we
right.
can hear you.
How about now? Looks like we're in. You know, it's always fun. It's an explore. Anyway, welcome. I'm your host. Tina's not here today. She's not feeling super great, so we're stepping in. And yeah, we're going to talk about 5.2, and it'll be a great time. We're really excited that we released it today. So hopefully you've gone and downloaded it, or you're planning on doing so. There's a lot of really, really cool stuff in it. So really excited to invite Juan and Tim and Greg. Welcome to the stream.
Hello.
We're excited to see you all here today. And yeah, we're going to dive into some of the awesome features, whether it's, there's a lot of cool stuff. What do we talk about? There's the procedural content tools are in, Substrate. There's a lot of virtual production updates. So we're going to take a small slice of those and go into them. So we're actually going to kick things off with Juan, one of our magicians behind rendering and graphics here at Epic. And so would you like to take it away and tell the folks what amazing things are now in the engine as of 5.2?
Thanks a lot, Amanda. I guess you can hear me, right? Okay. Um, I'm excited to be here. My last live stream was probably in 2019 or so, presenting
Ooh.
ray tracing for the first time. So we've done a lot of things since then. As probably all of you know, we released a lot of disruptive technology with 5.0, at least on the graphics side. We got well, Nanite and Lumen and TSR and VSM and a lot of things. And well, 5.1 and now 5.2 and eventually 5.3, it's all about expanding that, making it more stable, making it faster, making it more feature complete, rather than keeping adding disruptive technology every couple of months, because that would be just too much, right? So it's the biggest thing we did last year on the graphics side was to put all the 5.0 and 5.1 technology inside Fortnite. So we battle tested uh, Nanite and Lumen, TSR, virtual shadow maps, and so on in a game played by millions of people. So all that code, all those improvements and bugs fixed, and so on, immediately flow to the engine. So that was the biggest thing, right? And 5.0 is, and sorry, 5.2 is all about. It's a lot about that, about a lot of improvements in Nanite and Lumen and TSR that we did for a game. So we can say that they are production ready, at least for Fortnite needs, and hopefully also for you guys needs as well. So I can start with maybe with Lumen, just because that's the first one in the list for some reason. We did a lot of work on the high-end part of Lumen for 5.2. You guys can show, and yeah, this image is specifically on digital humans and virtual humans. We improved the SAS surface scattering model. We did, well, in general, big improvements for high-end. We improved GI and occlusion on characters for thin geometry, such as folds and nose and ears. Um, we improve high quality reflections on translucency. Now we support material roughness rather than being restricted to mirror only. We improve both the software retracing path and the hardware retracing path. Now the surface cache is driven by feedback provided by high resolution reflections. So feedback has higher quality, and that gives better quality on reflections. Let's see if we move to the next image. Yeah, lumen trees. And I don't know if you can see that on quality on the image, but we improved a lot rendering trees over occlusion and foliage that now we solve through, well, a much more robust algorithm using a stochastic distant field intersections. So lots of improvements in software ray tracing. Software ray tracing is the part of Lumen we use for games that need to hit 60 hertz, like Fortnite. We also made Lumen work in async compute, and not just in console, but also now in Windows. If we, well, I'll show a picture later. Can you go to image number 3? Thank you. We also improved noise a lot. This is a specific example that you can see on our blog entries for all the work that we did in Fortnite Chapter 4 for Lumen. I really recommend you to go to our blogs if you have not done it, if you have not done that yet, and take a look at all the work we did for Fortnite Chapter 4 and Lumen and Nanite and virtual shadow maps, and soon we'll publish something on TSR and local exposure and so on, because some of that work was in 5.1, but some of that work didn't land into the engine until 5.2. So I encourage you to read that. This is an example of some denoiser improvements that we did. Can you go to the next one? Image number 4. Okay. We also improve local exposure a lot and other parts of Lumen GI. I mentioned software ray tracing. I want also mention hardware ray tracing that now well, has way more accuracy, a better approximation of secondary bounces in reflections, better support of foliage, of two-side foliage. And we keep improving it. We are working in multi-bounce reflections for Lumen. They are actually already in our main branch. Yeah, well, our plan, as we have already published several places, is to keep working in both software and hardware ray tracing paths. One is faster and less accurate. The other one is slower and gives you a lot of quality. And depending on what you are doing, depending on your budget and the target hardware and so on, you can use one or the other. We are not favoring just one of them. Our goal is to keep providing solutions for all of you. So we will keep both in good shape and we'll improve both as much as we can. So that's probably all about Lumen. You can move to the next image if can you go to image number 5? It's just a quick sample of what async compute does. We now can overlap a lot of Lumen work, not just for console. We can do that for on desktop as well. There were some parts of async that were not working properly with hardware ray tracing because, well, some BBH computations and some ray tracing passes were not, well, they needed some refactoring. We also did that. So in general, that gives you more speed. This is all about performance optimization. So these options are enabled by default in general, but you can turn them off just to see how much time you get with one option or the other. And yeah, that's hopefully a nice overview on Lumen. I'll be happy to answer your questions if you have any. So let's move to Nanite. Can you switch to the next image? Okay. We are going to talk about this GDC demo that we presented separately, so I don't want to hijack this image. I just want to mention that we work a lot on foliage and on rendering trees for Fortnite. And on chapter 4, a lot of that was in 5.1, but some of the there are some bits that were on time for 5.1, so we put them in 5.2. Yeah, we are still defining what's the best way to render foliage with Nanite. Rendering massive amounts of foliage is still an open problem in computer graphics, especially if you want to ray trace it. How you ray trace a massive forest with millions or billions of leaves moved by the wind, it's an open problem. But we're making very good progress there. Fortnite Chapter 4 was a big milestone on that path, and we keep working on this. And this demo that hopefully you saw at GDC shows that we keep making good progress here. So can you go to the next one? Yeah, that's another example of medieval forest, and yeah, and also the next one. The next one is substrate now. I like to talk a bit more about Nanite. As I said, the same as with Lumen, the goal with 5.2 was to make it more production ready. After using it in Fortnite for a few months now, we have been able to polish it a lot to make it more performant, to make it more stable. We made a lot of improvements in the programmable raster path. That again, I recommend you to read the. I think the name is something like "Bringing Nanite to Fortnite" blog entry. There's a lot of information on the programmable raster path, the way Nanite renders work position offset, and well, it's an interesting read. It's one of the biggest things we did last year, and in 5.2 we have improved it even further. I'd also like to mention that in our goal of making Nanite more feature complete, we implemented in 5.2 custom defts, custom stencils, lighting channels, global clip lanes, and we made more work precision offset improvements to make it faster, to have less artifacts, to have more efficient computation of bounds. So we don't so we can basically only evaluate word precision offset when we really need that, because probably word precision offset is it can be slower than when you just have a static mesh, right? I think, again, that's all about Nanite. It's just an overview, but I'll be happy to answer questions. Next image, please. And that's substrate. We'll talk about substrate with Sebastian and Charles, hopefully, and the engineers, the great engineers that created this system soon, when we discussed what we did for our GDC Electrical Dreams demo. But basically, substrate is a future-looking material model that means to replace the suite of shading models like the default lead and clear code with a modular framework that will allow you to be more expressive and to create a lot of new surface appearances that were not possible in the past. You have vertical layering and you have horizontal layering, and you have a lot of power there. And that definitely is worth a separate talk just on substrate, because we really hope that you find this as promising, as interesting as we do. We know, we are aware of how disruptive can be to change the shader models. So that we are not doing that in a hurry. We are doing this in incremental steps, always keeping an eye on backwards compatibility, on performance, on being multi-platform. So yeah, we want to provide all the power of substrate without blocking anyone who wants to stay in the all shaded model for a long time. What else? Yeah, this is an image rendered with the path tracer. I don't know how many of you are interested in the path tracer. We started exposing a path tracer because we wanted to provide a tool for ground truths, for people to understanding how lighting should behave. So then you can tweak the real-time engine based on what you see on the path tracer. And that was a great goal, but at some point we saw that the path tracer had reached a level of quality where people started using it for final shots. We've seen this last year, and actually just a couple of months ago, some studios like Moving Picture Company and others producing final pixels with our path tracer. So we keep working on it. We have added a lot of things for compositing, for film. Like now you can make an object invisible to primary rays, to camera rays, while it is still visible for shadows or for GI or for reflections. We have improved a lot subsurface scattering code paths to make character rendering more accurate. We have added mesh decals that they were missing. We have we support more primitives now. We support spline meshes, and we added more parameters for controlling lights, like adjusting specular value. We also have a path tracer switch node that you can use for evaluating a different material. Specifically for the path tracer, as we did for real-time ray tracing, which is something that you might need if you want to use a path tracer and in the same scene, or you want to path trace a level that it's completely tweaked for real-time purposes, and then you can use the switch to adjust things for the path tracer without having to duplicate everything. We, apart from what I said on objects invisible to camera rays, we also added some basic support for holdouts, for removing objects from the path tracer image to make composition way easier. And we also have experimental support for toggling ray tracing and path tracing on and off in runtime. So you don't need to restart the engine when you want to enable ray tracing. And that's pretty cool, because that was a big limitation that we had in the past, and like you had to restart again. So yeah, lots of things on the path tracer. Really looking forward to see how people use this Unreal Engine for linear content and for super high-end visuals. What else? yeah, more ray tracing improvements. Just an example of the kind of things we fix. We like red lights, denoiser wasn't working well. We improved that. And if you move to the next image, the number 11, we have added quite some new ray tracing debug visualization modes. For instance, this one allows you to understand what's the instance in overlap, which is a key factor for performance when you have ray tracing enabled. So please take a look at the new ray tracing debug view modes, because they are instrumental in order to optimize your scene if you have ray tracing enabled. Yeah, if you go to image number 12, thank you. This is actually one of my favorite things from 5.2, at least on the graphic side, which is the part I'm more familiar with. This is the render resource viewer. It's a tool that will help you to optimize GPU memory. It displays where all the GPU memory is going. If it's going to textures, it's going to buffers, what render resources are using it, which vertex buffers, which index buffers, and you can inspect the asset they are coming from. You can identify this is a static mesh, if this is a dynamic mesh, if this is something else. We did it for ourselves for the Matrix Awakens and Fortnite Chapter 4 projects, and it was extremely useful. I can share our experience that for us it was instrumental for optimizing and for shipping. So I'm super happy to see that now for all of you as well. What else? If we go to next image, is a variable shader rating. This is still experimental because previously it was just available for XR devices, and now it's also possible to use it on desktop. Remember, it's experimental, as I just said. So it supports contrast adaptive shading, which uses information from the previous frame to determine which areas can be rendered at different shading rates. So yeah, we added this new debug visualizer mode to the variable rate shading manager, so you can see how this is affecting the scene in real time. So again, we hope that this feature is pretty useful for you. I have also something else. I could mention a few more features, but I like to stop in one in particular, which is that we think we have got rid of PSO hitches on the X12, which is a big thing that probably some of you or many of you have seen in games shipped with Unreal Engine and the X12. It was a big problem in EU4. We started working on that and very seriously in 5.0, some more improvements in 5.1. And now in 5.2, we can say they're pretty much gone. We have a precaching PSO system that will hopefully make the old manual caching system not needed anymore, except in really extreme cases. Basically, we just wait for the PSO to be compiled before we draw something. So in some cases, it can increase popping because we are waiting for objects to get ready. So at the very end, you can detect some small popping. But so maybe the game will need to do some housekeeping to make sure they keep the loading stream for enough time. In Fortnite, actually, we now extend the time we present the loading screen, so we keep caching all those PSOs. But it really pays off. We think there's no more hitches, and we are super happy to share that with you. Yep.
Ooh,
And
the secret
I
surprise
could
of the
talk.
stream. Who knew?
Yep, and maybe people knew. I don't know. Maybe somewhere. I think so. It's in the release notes somewhere, but I think it's a big thing. I probably were not promoting this as much as we should. At least I'm not doing that. So I'm changing that today. I'm saying that openly.
So
Yeah, I
if
could
it were up
talk
to you,
about.
you'd just move it to the top of the release notes, huh?
Yeah. Yep.
Go ahead.
Probably. So I think that's hopefully that's a nice, interesting overview of where graphics are in 5.2. I don't want to steal more time from my colleagues, so thank you for your time and for listening.
We've got a few questions for you around the graphics and whatnot. So one person was wondering if the lumen changes that you discussed apply to in-display on LED walls as well for in-camera VFX.
Yes, I didn't mention LED walls and multi-view. We did a lot of work on multi-view and in-display because virtual production and LED walls are critical for us.
Mm-hmm.
It was hard to run Lumen there because when you have a lot of views, we were CPU bound. We had really serious performance issues on the CPU side when you had lots of views. We have improved that a lot. Like we have a submission thread with like makes things way more optimal. We have removed some GPU stalls that were affecting like when you have several views, things were not properly designed. So we fix all these things, and now it's possible to enable more lighting effects, including lumen in LED walls. We use that internally for our LED wall project. So we have to make it work.
Well, that's fantastic. That's awesome news. Let's see. They're wondering, are we planning to allow BRS factors to be controlled in a per frame manner by developers? For example, if they wanted to do eye tracking based BRS.
That's a good question. It's TBD. I'm sorry, we need to discuss it further. I'll talk to the owners of that area because I don't want to overcommit ourselves. I'm sorry, I don't have all information.
No worries. I
I'll
know
give you
we've
an
also had a
answer
couple.
I'll give you an answer soon if I got it, so we can share it with the community. But yeah, I need to
All
talk to
right,
folks first.
perfect. I know we also have quite a few questions about substrate, but I think it's probably best we're going to have a specific stream about that at a later date, and so we'll get into the nitty gritty just for the folks at home, your benefit. We'll dive into those, but hold on to those. Those are great questions. On generally, now this isn't necessarily a specific graphics question, so anybody can feel free to dive in. But somebody's asking if we have any guidance on how frequently or how often to upgrade their project, and if you ever recommend holding on to older versions or any guidance around sort of that piece of the workflow. You know, we're seeing a new engine version. Do you recommend folks jump immediately? Do they keep a version for a little while as they try to upgrade? What are some of your thoughts in that space?
Oh, that's a good question. It's a lot of responsibility to give advice on that. I don't want anyone hates me forever, but we knew we were too disruptive from UE3 to UE4, and we really wanted to do things differently from UE4 to UE5. So we definitely didn't see the same level of disruption, even going from 426 or 427 to 5.0. So going from 5.0 to 5.1 and 5.1 to 5.2 is generally very smooth. We do that all the time internally for our projects. Like we have Fortnite and we have other games that they need to update to latest all the time, and we can say that this is not at all as disruptive as it was in the past. And so in general, we encourage people to stay up to date, but that's just general advice, and you might have specific circumstances that force you to stay with the same version. And that's just my personal opinion. I'm pretty sure, yeah, you probably have a different one.
Feel like you don't get the new features unless you update, but obviously, right, it depends on how
Yeah,
deep in a project you are and things like that. You know, what is the lift? What are the
mm,
advantages to moving ahead and not? But I don't think it hurts, right, to keep a backup, then do your upgrade, see how that goes, and then if it all goes smoothly, then
sure. Yeah,
source control
and
is a valuable thing.
Greg or Tim, if you want to say something about it, I mean, that was just my personal take on it.
Yeah, I would agree with your take about versioning in terms of our current process, how it's less disruptive. It really depends on the project, I gotta say. If you're, in the game space and you want to ship and you're really confident with, current version, even though the new shiny features might look awesome. I mean, obviously I would just say, stay stable, right? Because you want to ship it, right? But if you're, in more like the linear content space, if you're interested in more of the stuff that's more on the editor side rather than runtime side, then yeah, consider it at least. We're always looking to improve the workflows, and I definitely want more feedback just across the board. So yeah.
All right. Thanks for the insight. Let's see. They also wondered if there was any news or updates on Nanite support for the path tracer.
Nanite support for the path tracer, you said?
Mm-hmm.
Well, it's already there. There is a CBAR. I don't remember it's a syntax. It's just CBAR madness, and it's something like r.pathtracer dot or r.nanite dot ray tracing dot enable or something like that. But it's actually there. What it does is that it dumps nanite buffers and puts them in a BPH, and then we ray trace them and we path trace them every frame. So you trace against the final quality. We are not using a mesh proxy with lower resolution. You can use real geometry for that. So obviously, it's not very fast, but for path tracer purposes, it works. We use it internally, and definitely we encourage people to use it. I can share the CBAR later. I'm not very good at remembering CBARs anymore. Yeah, it's hard. Yeah,
There's just too many.
this is true.
Let's see.
Sure. I promise.
What are you promising?
No, I promise that it's there, that you can use it.
I'll always believe you.
Yeah.
Let's see. Somebody had a quick question, or they mentioned they're referencing the PCG demo. They mentioned they grabbed landscape icons and moved them to change the generation of the landscape. What is that feature actually called itself? Or do you know?
Sorry, what's the question? Can you repeat it? I was a
Sure.
little confused.
In the PCG demo, they grabbed the landscape icons and moved them to change the generation.
Yes,
What is that feature called? Or is that just part of PCG?
it's part of PCG. Yeah, I don't know what's the specific name.
No
I'm sorry.
specific.
Yeah,
That's all
graphics
right.
is just too big. I have very little
Don't you
expertise
know
in PCG.
everything about graphics?
Yeah, but that's more PCG tools. Yeah.
Yeah, no worries, no worries. All right, well, we'll go ahead and wrap up the graphics portion of that. Thank you so much, Juan. Really lovely information, and I'm sure questions will keep trickling in. So we're going to move on and jump over to see what Greg has to share with us. A lot of exciting updates around sequencer and animation incoming. So want to give the folks a little bit about who you are, what you do at Epic, and then we can dive right in.
Yeah, sure.
It's
So
good.
yeah, my name's Greg. Oh, sorry. My name's Greg. I'm the product specialist for sequencer and retargeting. And yeah, happy to share all the new features that are out in 5.2. Um,
Awesome.
yeah, I think we're gonna share our screen for some of the release notes. Hey, awesome. So yeah, the first thing on there is in regards to movie render queue and console variable presets. I know that Juan was just talking about how many CVARs there are in the new. I think in the new console variable editor, there's a autocomplete now, so you can just like type and then it'll just autocomplete what you know vaguely what you might be looking for. But basically, in this beta feature, what users are able to do is preset CVAR assets into movie render queue. And what that will do is instead of having to, you used to have to like put them line by line, and that's got quite annoying if you have like 18 CVARs able to do. So you can have like a preset asset that you can load and also override if you want to per movie render queue job. So which is super exciting. Something else that we added in was with subscenes. So you can now blend subsequences. So if you're familiar with sequencer tracks, most sequencer tracks you can just kind of put the sections on top of each other, and then there's some sort of blend curve that you can, pull apart just to blend between those two sections. Well, now this also works for full subsequences, and you can do that within the editor. Or if you have like level sequence players in your runtime setups, within blueprints, you can have weighting on that as well. So you can control some of that. So this is useful for like material blends if you have like animated materials or like changing the seasons. Or if you have like some shots that you want to blend together as well for like animations, and this works for any blendable tracks, and super powerful. Something else that I want to mention is in the transform sections, there's now a option to use a quaternion interpolation blend, which allows you to take kind of the shortest route between poses, in particular for transformation sections. Going on to the next one, we have some improvements on blending root motion within sequencers. So for those that are in like the mocap world or just kind of in any sort of animation world, you might notice that some animations kind of come in with motion on the first bone of the skeleton, where that's where the main root motion is. However, there's some animation libraries that have motion on, say, like the hips or something like that. That's not directly onto the first bone of the skeleton. So a while ago, we had introduced this option called blend first child of root, and what that does is allows you to blend basically the first animated child. So it doesn't just do the full path from root down to all the other bones. It'll just blend directly onto the first animated child of the first bone, which is super awesome. So that users can kind of use a mixture of libraries of animations together. And what we did do to improve this, though, is when you do any sort of root motion matching, so when you're like blending the clips together and then using the right click menu to match the bones based off of however many clips that you have together, what that will do now is the manipulator will always follow in the match space. So when you're scrubbing, you'll actually see the manipulator move based off of that kind of first animated child bone. So you can then do additional offsets on each clip if you need. And that's super useful for motion editing and kind of putting all your clips together. Next one is more about like organization and kind of like quality of life. These are You're now able to individually color your shot sections, and so you can use this for organizing different parts of like your audio or different parts of your shots. If like one's voiceover or one's music or something like that, or if that this subsequence is just for like animation, while this other is just for like VFX or lighting. And we have some really nice options. If you right click on any of like the tracks, you can set the color tint for the whole track row, which is super nice. So if you have like multiple sections across one track row, you can just set that color immediately without having to individually go into each one. And this also works for skeletal animation. So you can see that in this image, we have 3 clips going on, and when you draw the skeletons, it'll actually match the same color that you have assigned to the section. So that makes it easier to just see what you're kind of blending and kind of debug while you're scrubbing through the timeline. If we keep going down, We've done a lot of improvements to frame markers. So frame markers can now be multi-selected, so you can select multiple frame markers. And they're easier to see and rename, so you can right-click on any of them and change their colors quickly, and even change where the frame numbers are. And you can also add some comments to them. If you hover over the marker, you can kind of see what comment that is. So if you're collaborating with multiple folks, you might see a marker like, oh, I wonder why they put that marker there. So you can hover over it. You can see, oh, okay, that's there for maybe some timing purpose or something like that across the whole sequence. And this also has the ability to have deterministic fencing. So you can mark it as, hey, I really want to make sure that I get accurate playback in runtime. And if you see I think that's a GIF on the second image. I don't know if it'll play across, but yeah, I don't think it will, but that's okay. Basically, that will showcase how easy it is to multi-select across multiple frame markers. And if you have subsequences and you're kind of viewing across like different trees and such, you can actually see the frame markers across. So if you have like frame markers in one subsequence, and then you're in your root sequence, and you're like, oh, I don't know where my markers are, so you can actually see them across subsequences as well. And that's pretty much all the major sequencer features for 5.2. And we can go on to retargeting.
Real quickly on sequencer, somebody's asking if it's possible to add a cloth simulation to sequencer.
Yes, you can do some simulation caching. I don't know off the top of my head which cache that is. I think it's just the Alembic. But yeah, you can add your cloth sim move in there. Niagara also has their own implementation of caching within sequencer as well. So you can kind of like do a pre-cache on playback. And I think that same system is for cloth. I'm just not quite sure of that, but I can look back into that.
No worries. Thanks.
Yeah. For retargeting, something that is super big and I'm excited to announce is that retargeting now has Python support, which means that you can completely automate and expedite the retargeting process within like IK rigs and IK retargeter. And we have full documentation around this too. So I think some links should be shared in chat, but feel free to look at those. We're super excited about this since that was a big request from multiple folks that want to fully automate their retargets and quickly create IK rigs and retargeters. Something that isn't mentioned on the release notes is, and something that we get bugged about a lot in retargeting is we did improve how chain authoring is done. So you don't get a bunch of pop-up dialogues anymore. It's kind of just this one dialogue with options that you can manage now in 5.2. So that's much easier. And I know that was a big pain for a lot of users. So that's something I wanted to highlight as well. And then for mapping, we added some new options to the auto map to where you can actually map exact names on your retarget chain. So previously in 5.0 and 5.1, we only had a way to map retarget chains like fuzzily, so it does like a fuzzy string match. But now we actually have an option to map the exact names of the retarget chains, which is super useful. And not only that, but that also allows you to do it on all, or maybe map them only on the empty ones, or you can even clear all your mappings. And this also can open up future mapping implementations if anyone in the community has more mapping solutions if they want to do. And that's pretty much it for sequencer and retargeting.
That's great. Lots of good stuff in there. And let's see, we have some couple of questions. Let's see. I don't know. how do you or can you access inverse kinematics with procedural animations?
Yeah, so you absolutely can. You can do that via, the Anna Blueprint route. So some of the things that we've done in the past is use a post-process NMBP that can do like kind of secondary animation. That also works with control rig as well. If you recall in our Valley of the Ancient demo with the big robot, all of the wheels that are kind of moving inside the robot and the pistons were all just secondary animation that was procedural. So folks can, author their animations on the robot, and then it would just automatically have the wheels spinning. So you can have a procedural secondary animation. And if you wanted to add IK, yeah, you can. In our Lyra example, I believe we did something there with the foot plants, where we use full body IK as a post process to handle the foot planting and slope warping.
Perfect. That's awesome.
Mhm.
Thank you. Let's see. Is there a way to dynamically generate a skeleton via blueprints or Python?
Dynamically, I don't think so for the time being. There is some things in the works around that, but that's all I can say at the moment.
All right, maybe something to look forward to.
Yeah.
Is for the crowd, I guess, do we know if the Lyra project has seen or will be getting a feature update as it did with 5.1?
Oh, I'm
Since you
not
mentioned it.
sure.
I haven't heard anything for 5.2, but I know that the team is actively looking at ways to improve that. I don't know about features though, off the top of my head.
All right. Let's see. And then I think I don't see any additional animation ones at the moment, but if they come in, we can always pop back. So in the
Definitely.
meantime, thank you so much, Greg. And we're going to jump over to Tim, who's going to dive in about the new ML deformer sample, if I can say it, and has some very cool things to show us. So let us know what you work on, Tim, and feel free to dive right in.
Great. Can you guys hear me?
Yep.
Mhm.
Yeah? Okay, great. Can we go ahead and go to the slides? Right, so I'm Tim, and I'm a lead animation programmer on the engine team, and I'm part of the team of artists and engineers that have been working on the new machine learning deformer system that we've updated for 5.2. And the goal is to bring the same level of deformation quality to bodies that you can see in the faces of metahumans, for example. So if you go to the next slide. So if you go and play the video, sort of get an example of what a typical body deformation setup looks like for a character. And this is actually our metahuman skeleton. And what we're doing is using a combination of helper joints and corrected blend shapes. And that's to preserve volume and silhouette. But the issue is that human biomechanics is really, really complex. So you want to do things like show the scapula moving underneath the muscles or skin sliding. It's really, really hard to do with these types of techniques. So if we go to the next slide, go ahead and play the video. So what we want to do is bring our characters to life with really awesome muscle and flesh simulation. In this case, you're seeing what is possible in Houdini with their Vellum solver. And the deformations are looking really, really good, but you can see in the image there, it takes about 1 minute per frame to solve this quality of deformation. So if you go to the next slide and play the video, we think it'd be great if you could have that same level of deformation quality, but be able to do it in real time. And so that's what you're able to do with machine learning and the ML deformer system. So what we're doing is we're compressing all that simulation data down to a format that we can run in real time. And so you're looking at our ML character, which we've released today as part of a sample. And the deformations are driven by full muscle, flesh, and cloth simulation the simulation data is from Houdini, and it's running in real time. So if we go to the next slide. So you can check it out for yourself. That's the best way to sort of see how it works. Go ahead and download the ML deformer sample. It's around 30 gigabytes, and it has all the training data. It lets you really take a look and understand exactly how the system works and how you can use these type of techniques. If you go ahead, actually, wait a second. Hold on a second. I just realized I have one more slide, I think. Go to the next slide. Just talk about the character a little bit. So the character in the sample made up of 7,000 frames of simulated data for the cloth. And then we did another 7,000 frames for the muscle and flesh. And then we trained 2 different machine learning models. So go ahead and switch to my screen. And can you guys see my screen now?
Mm-hmm.
Yeah, great. Okay, so this is the ML deformer sample open. And if I go ahead and play it, you'll see those same results from that video. You can use the up and down arrow keys on your PC to switch the layers. So this is the flesh layer. There's the full muscle simulation, so you can see what the actual underlying simulation was. And then we're also doing a cloth-based deformer. On PC, you can hit O to enter into an orbit camera and get a better look at how the system is working. And also we have some performance stats to give you an idea of sort of how fast the whole system is evaluated. Go ahead and show you some of the assets that make it up. So it's all inside of the characters ML directory. And if you go down to the deformers, that's where we have all the deformers. So there's a flesh deformer. You can see the 2 different cloth deformers that we're using as well. Probably the best place to start is with this MLD NMM flesh upper. And what those somewhat cryptic names are referring to is the neural network type, so the machine learning model type. So in this case, it's the neural morph model. And when you open it up, you'll see that there's 2 different tabs. So there's a training tab, and there's also a testing tab. I'll take you through the training. So to train a machine learning model, we need to provide it with a lot of sample data. So in this case, we have 7,000 frames of sample data. So you can scrub through the timeline. It looks somewhat crazy because it's all randomized data, and we need that randomized data to make sure that we get a good generalized machine learning model. You can also see some performance statistics, which is might be interesting, and that's in microseconds. So we're talking, 0.025 milliseconds. We can switch over to a testing tab, and this lets you test out the quality of your ML deformer. You can go ahead and turn on a heat map. So if you turn on a heat map, you'll see where the deformer is active and how much it's active by. That gives you a good sense, how exactly the deformer is working. Another thing you can do is you can change the weight. So you can slide the weight up and down, and you can really see how much of an impact the machine learning deformer is having. And you can use this UI, train your own machine learning models as well. So that's the neural morph model. We also have the nearest neighbor model, which is specifically for flesh. You notice a slightly different editor because it's a different machine learning model. In this case, you can see results of the cloth sim, and you can see in which of the nearest neighbors, which is basically a cloth wrinkle pattern that we're overlaying on the top to give you the best machine learning results. Also, it's worth checking out the actual training ROM. So this is the upper body flesh. This is our 7,000 frame training animation. If you're thinking about using the system yourself, it's good to learn how to structure your data. We also have released a Maya plugin to help you generate all of these different random poses, so you can then come into the engine and train your simulation. Also worth noting that you'll have to have a paired geometry cache. So yeah, that's a lot of the data in this sample is actually the large geometry caches in the project. So if you go ahead and stop sharing my screen and let me know when we're back to the presentation. Great. Great. So what we were focusing on for 5.2 as a big focus was on performance, because we want to make sure this is a practical technique. So as I mentioned earlier, the flush simulation that you were seeing, that's 0.02 milliseconds on the CPU. And on the GPU, that was 0.9 milliseconds on a PlayStation 5. So we think it has type of performance characteristics that you need to actually release it in a shipping game. There are some different parameters you can tune in the models that will have an impact on the quality and the CPU and GPU time. Things like changing the compression level or the size of the neural network itself. The neural network makes use of morph targets. That's how we get such good performance, is using our morph target system. And so obviously compressing those morph targets more or less might have an impact on the quality. So that's all I wanted to show you for a really, really brief overview of what we've done for the 5.2 ML deformer system. And I really hope you check out the sample and play with it yourself.
Awesome. Thank you, Tim. We actually have a bunch of questions around here, if you don't mind.
Yeah.
So they were wondering, does it, first off, they're speaking of how it works with heads for metahumans. So would it work with both the body and head for a metahuman itself?
Yeah, so you can train a machine learning deformer based on sort of the faceboard curves to drive a metahuman head. I wouldn't say that that's necessarily the best use of the technology. I think that the metahuman already gives you really good deformation results, but you could train a model for that. You probably would then, you probably have a separate model for the body and the head in that case. And we do have some options to help you stitch together two different mesh segments with different machine learning deformers on it. The issue is that at the vertices where it merges, if you had different deformation results, you might see a crack. So we fade out there's a way that you can fade out the deformer towards the seams to make sure you don't see any cracks. But yeah, you could.
Okay.
I wouldn't recommend it for the face necessarily. In the same way,
Uh-huh.
you'd probably be better off just using the metahuman straight up. But people have done it, and we've gotten reasonable results.
All right, perfect. Very cool. Let's see. Does the deformer work with grooms or physics assets when multi-hex options are set for the physics shapes type?
Yeah, so there was actually we did have grooms. I don't know if you saw. You'll see it in the sample that there's some chest hair and some arm hair on the ML character. So yeah, it does work with grooms. What was the other question? As if
Physics assets when multi-hex options are set for the physics shapes type. I understand it's
I'm
very
not
specific.
sure about the multi-hex options for the shapes, to be honest. So if it's something evaluating, the deformer runs after the skeletal animation has been evaluated. So if you had a physics simulation that was affecting the skeletal animation, then the deformer would run after that. So it potentially work in those circumstances.
Perfect. Let's see. Do you see the deformer working with stylized characters or creatures? So if they're bringing their own
Yep.
characters in, it'll just work?
Yeah, so yes, it doesn't have, I mean, the machine learning model tries to learn the difference between the linear skinning result and the complex deformation result that you're bringing in via your geometry cache. So you're basically training it with thousands of samples, and it's basically saying when the model is in this pose, like, whatever crazy pose, right? What is the difference between basic linear blend skinning and the deformation result, right? And that can work with a wide range of characters. We're only looking at, for most of the models, joint rotations. So if you had something that was heavily dependent on translation or scale values, you might have to do some more work on your rigging setup to make it work with the machine learning deforming model. But in general, yes, it should work with cartooning characters or stylized characters, yeah.
Well, cool. Expanding on the kind of characters that it can work on, we've had some folks asking about loose-fitting clothing like dresses or trench coats or larger
Yeah.
characters, right? The
Yeah,
gentleman here was
yeah.
very lean. Would heavier set individuals also
Yeah.
be simulated well in this?
Yeah, that's something I didn't call that out, but it's something important when you're thinking about this machine learning model. So it learns quasi-static deformation. So basically, there's no dynamics. So if you had something that was really fat with a jiggly butt, like belly, right, and the dynamics were really key to the motion, and basically, so it's not just the static pose that influences the deformation; it's the way that the character arrived at that pose that's changing the results, right? And in that case, you're not going to get those deformation results because there's no dynamics in the system. So if you have really good-looking deformation, but it's static, then we can reproduce it. But if it's heavily influenced by the dynamics, then it's trickier. Which is going back to the cloth. That's kind of the answer to the cloth situation as well. So when you look at the sample, you'll see that we have jeans which are tucked in the boots. The jeans are also tied around his waist, and the shirt has cuffs, right? And the reason is because if the cuffs were sliding up and down, that's a dynamic motion, and we can't handle dynamics in the system, right?
Mm.
So yeah,
Okay.
so definitely, like, if you had to really imagine a floating skirt with like it swirls around, it's really not going to be the right situation for that kind of character.
Yeah, makes sense. Let's see. I know you briefly touched on performance, but they're kind of curious, like what's the impact itself? Could you have hundreds of characters using the deformer at once, or what are the costs then for that
Yeah,
work?
yeah. So the neural network that it's evaluating is really tiny, actually. So it depends on how many neural networks you're running and the complexity of them. But in general, they're really, really small. And the reason they're really, really small is we've pulled off the majority of the work onto the GPU into the morph target system. So you'll see in the stats alive when you run the sample, like the flesh was about 18 megabytes of memory, right? So there's going to be a memory hit every single time for every character. So depending on your model and how much memory you're willing to dedicate, that's one limitation. In the sample, we're running 3 deformers at the same time. So we have the pants, the shirt, and sometimes 2 usually. So it's either the flesh and the shirt and the pants, or it's the pants and the shirt at the same time, right? And you can get up to a couple hundred megabytes of GPU memory being used for those models, because the cloth model has to store additional wrinkle patterns basically to get the fine folds, and those take a fair amount of GPU memory. On the CPU side, the neural networks are really quite small, so about 20 microseconds to evaluate depending on the model complexity. Let's say between 20 and 100 microseconds per model, right? So you could reasonably run 10 or 20 or even 100 if you really wanted to put the CPU budget at it, right? But you're going to be bounded by that. You pay that cost per character.
Wonderful. Awesome. Thank you. Let's see. Can any asset use the deformer? So what types of pre-setup or setup needs to be done against an asset to prepare it for use as a model in this case?
Can any asset use it? You have to add the ML deformer component to it, and I've only tested it with skeletal mesh. I haven't tried it on another mesh, so I think probably on skeletal meshes, and you add the ML deformer component. Yeah, I'm not sure if there's any limitations beyond that, so I should work with skeletal meshes, but I haven't tried it with static mesh.
So you can try, but no expectations. They're wondering, does it work? So there's the experimental chaos flesh, and so they're wondering if this would work in tandem with that.
So at the moment, there's no sort of interaction between those systems, and so not at the moment.
All right. See. They're asking at a high level, what are the main steps to sort of walking through this? So, you mentioned setting up a skeletal mesh and applying the deformer. Is there, obviously we like the documentation. That'll be nice to dig into, but sort of what's the TLDR to getting started?
So the TLDR is really the training data. So the work that most people are going to have to do is really on the data side, on the tech art side. So the stuff you're doing in Unreal might be the simplest part of the pipeline. So it's really looking at the random training ROMs that we've shipped and figuring out how to generate the same data in your pipeline. Then you will export a paired of an Alembic cache that you'll then turn into geometry cache. So wherever you're doing your more complex simulation, you need to create a paired cache, and then you'll bring those into the ML deformer system, and then you'll train your model. And then you'll be iterating on your model to make sure it's accurately representing in the training data. And usually when things go wrong, it's probably, often it's a situation where you didn't have enough training data, or there were errors in the training data, and that's what's causing the problems.
Wonderful. So hopefully that's a good overview and gets you all excited to go dig in even further and start deforming all of your peoples. Let's see. I know that's the very technical term. I hope you know. I hope you were ready for that. Let's see. Does this deformer have anything to do with the deformation on the wheels? So folks were referring to the demo we showed at GDC. Nope,
No,
totally different.
that was the flesh system. That's the flesh system, yeah. So it's a different system.
Oh, it was okay. So that's what, Chaos Flesh?
Yeah, I believe that's Chaos Flesh.
Mm.
Yeah.
Now the people know. Let's see. Then Juan, we had, I think, Greg, we had one for you. Will procedural and dynamic animation be compatible with VR?
It depends on your memory budget, I guess, and your hardware limitations. I mean, uh, yeah, I mean, it works. It works for all platforms, I guess. But yeah, it just depends on what kind of procedural animation you're kind of looking for. Yeah, I don't quite know what else to say about that.
No problem. Hey, sometimes we just don't know. So that's the reality. Let's see. Juan, they're wondering, is there any word on per instance vertex painting for nanite, or a potential alternative in-engine workflow to make painting to the nanite mesh in order to avoid painting outside of Unreal?
Yeah, we are aware this is an important issue. There is work. It's mostly theoretical work so far. We are still trying to figure out what is the best way to go. But this is one of the biggest limitations of Nana we want to improve. And so yeah, it's in a radar for sure. It's in a roadmap. We just cannot give an ETA. Even we don't have we cannot share a solution yet because there's still some loose ends. Yeah, sorry. I love to say yes, but it's a yes in the future.
Hey, no worries. You have a longtime fan, they say, of many decades, and
Wow,
their suggestion
very
was
old.
substrate looks like a MW render 2 plus material, but seems to be an evolved node-based version instead of linear. And they're wondering if you could share any anecdotes regarding that. This is a little beyond me, but
Yeah, I guess he's talking about my former job like a million years ago on a patricia called Maxwell. We had a multi-layer material, and probably he's asking if this is similar or is it different. First of all, I didn't write a single line of code on Substrate. It was mostly Seb Charles, and Substrate is entirely focused on real-time rendering. And what this person is talking about is a multi-layer system with stochastic evaluation of different layers depending on where the ray was, like a super ground truth, very heavy, and mostly like a multi-layer proper simulation that you can use for optics or lens design or things like that. This is very focused on real time. So it's similar in the way that it's multi-layer, horizontal and vertical layers, but that's pretty much the only similarity. The rest is very different. Even the authors. Yeah, I'm not involved really. I'm just they're part of the team, but I'm just helping them and trying to unblock them. I'm not writing any code on Substrate, and sadly, in pretty much any area these days. Yeah. Just some one-liners from time to time, and that's it. Yep.
but I bet they're very important one-liners, so don't sell
Of course,
yourself
yeah.
short.
Most important ones. Yeah. CURs. Yeah.
Let's see. is there any word on translucent support for nanite meshes?
Yes, it's another thing we want to tackle. Actually, we start to know what's the way we want to go. So there is progress inside our brains. There is still no progress in like in the code base. But yeah, absolutely. Our plan is that everything is nanite. We have this internal roadmap that is nanite everything. That means everything. We don't want any primitive or any particular case that goes through the old static mesh rendering path. So translucency is absolutely part of that. If this is going to be 2023 or 2024, I don't know. The sooner the better. But we know that we have to do it, and we have a good idea on how to do that now. Well, we have high level idea only. Of course, implementation details are going to be tricky, and we are still not there.
Perfect. Let's see. I don't know if this is the crowd, but they're asking if we have update on level instances and when we think they might be production ready. I don't know that this is the group for that though.
Not sure. I cannot
Nope,
speak about it.
Yeah, no, can't speak on that.
Yeah.
All
Sadly, yeah.
That's all right. Well, I think that's probably all the community questions we'll gather today. I do want to leave with one final question. What has been your favorite feature or update to 5.2 around the table?
My case, allow me to pick two. All the incredible work made with substrate materials by Seven Charles, and also removing PSO hitches. That one is really big. It's affecting a lot of games have already shipped. So yeah, those are my two favorites. I'm sorry, I just didn't pick one.
That's okay. We'll forgive you this time.
Like you're putting me on the spot. I have to choose between like we're targeting a sequencer. I feel like I have to choose at least one between the two, or one for each of them. For we're targeting it's the Python stuff. That stuff is uh got a lot of love, and that's something that we're super excited to release to the public. For the sequencer one, I'd say it's the I feel like it's a toss up for me sometimes, but I'm gonna go with the subsequence blending. That just unifies a lot of our blending workflows, and it's a super powerful feature that I know a lot of our users are going to use.
Perfect. Are you just going to choose the whole deformer?
I'm just choose the whole deformer. Yeah, no. I mean, I think I'm really excited about Substrate. That looks amazing. I'm excited about that. But yeah, obviously I'm really excited about the deformer and everything that he's put together on the deformer. The sample in particular, actually. I'm excited about that.
Awesome. Yeah. So, one, I want to thank you all for joining us today. This has been a lot of really fantastic information, and I hope those at home got a lot of value out of it and diving in and being able to, answer some questions live. We do have more 5.2 streams planned, so we've got some about procedural content generation and other things. But if there's anything you all want to see too, feel free to holler at us on the forums and let us know. We're always watching over there and would like to see what you're most interested in learning more about as well. So again, thank you so much for stopping by today. Please send all the love and attention to Tina and wishing her well. And we will certainly be back next week. And in the meantime, I hope you've downloaded 5.2 and some of this incredible sample Tim's been showing off. And just a round of applause for all the work our dev teams put in, all the really cool things that they make, and hopefully you all have a good time working with those tools. So have a fantastic week. Thanks again to the folks here and at home, and you all be well. We'll see you next time.
Thank you. It's been a
Cheers.
pleasure.